Hey Arden, so there's a couple of ways we can do these. We can do them by graphing, we could do them by test points or sign charts. Everyone's pretty terrible at sign charts, so I would say either test points, which will be good for the rational functions coming up, or graphing are the way to go. So if you're going to do this by test points, which is like I said, what we'll do when we have rational ones where there's division, we would either way we would want to find the zeros. So x is 0, x is 3, or x is -7. So if I was going to do test points, I would set up bing, 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 not drawn to scale, -7, 0, and 3. I would just set up a number line, and then, no, I don't want a sticky note. There we go. I would pick points on each of these intervals and then figure out whether or not it came out positive or negative. So I would probably check -8, because that would give me this interval. I would check -1, because it's an easy number, and that's in between these two. I would check 1, because it's easy, and I would check 4. And so you could put -8 in here and grind all this out and figure out if it's positive, negative. You put -1 in there, grind it out, figure out if it's positive, negative, same thing all the way across. I find that one annoying because I really hate evaluating functions at points, and you don't need to do it all the way. You just need to figure out the sign. So, for instance, I'll do the easiest one. If x was 1, this would be a 1. This would be 1 minus 3 would be -2 squared, so that's positive, times 8 is a positive. It doesn't matter what number it is, but between those 2 points it would be positive. So you could go through and do that, and that would give you your positives and negatives and where it's greater than or less than 0. For these ones, I do prefer graphing just because I think it's easier. So if this is -7 and 0 and 3, and so these are going to be my intercepts, then what you do is you count up the powers. So this has 3, 4, 5, because it's squared, 6, because it's the first. So there are 6 x's here. And x to the 6th is positive and even. And so if we go back to, I think it was maybe the section before this, we're working, yeah, it's 4 point, oops. I think it's 4.1, graphing the rational functions. So if we're doing that, positive even is going to look like x squared, positive odd looks like x cubed, negative even looks like, the x squared but reflected about the axis, and likewise for x cubed reflected about the axis. So what I would do over here is I'd say, okay, it's x to the 6th, it's positive even, so it's going to look like this function. Whenever you have an odd power, it's going to cross at that power. When you have an even power, it's going to bounce at that power. So at 0, we're going to have a cross. At 3, we're going to have a bounce because it's even power. At 7, it's going to cross because that one's an odd power. And positive even, again, looks like that. So I would start up here, I'd come into 7, and I'm going to cross on 7. That was just a